Hello, this is Vitun Hemsuwan. I come from School of Mechanical Engineering at Sonora University of Technology in Thailand. Okay, and for this video, I will introduce about the CFD software using the computer simulation, and I will using the S3 Tetra. This is the CFD software of the Cardle company. Okay, and the first I what is the CFD? The CFD is the computational fluid dynamics. Okay, this is the tool for solving the engineering problem in fluids and heat transfer by using the numerical simulation techniques. And this software of the S3 Tetra is the software based on finite volume method to change the PDE, partial differential equation in fluid dynamics, okay, to the algebraic equation, okay, by using the finite volume method, okay. And okay, if you want to investigate the indicate the problem, the fluid dynamic problem, okay, by using the numerical simulation technique, you have to set up with 3 steps. Okay, for example, if you want to indicate this the aerodynamics device of the vertical axis wind turbine, right? If you want to indicate this system by using the uh, numerical simulation technique, you should choose prepare with 3 steps. Okay, the first step of this system is called key processing. Okay, you should to set up the geometry. This is the geometry. This one, this is the geometry of the aerofoil, and this is the shaft. And you should to prepare the fluid domain, including with the inlet, right, and the outlet, or the upper and lower sides of your domain. Okay, in this step is really important. You should to think about the 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 accuracy of your results, and the 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 computational cost of your simulation. Okay, for example, in the real system, this one is the three-dimensional problem. Okay, in this case, if you see when the span wire of the turbine base is long enough, okay, yeah, the flow behavior at the middle of the cross-sectional area of the turbine bed, you can see the behavior looks like the two-dimensional flow, right? In this case, we can model the t-dimensional to two-dimensional for reduce the con to reduce the computational cost. Okay, this is the first step of the geometry generation. Okay, and the second step is the method generation. You should to generate the method of your fluid domain, right? In the far field, you can set the mix method, and the mesh code to the solid surface. For example, the surface of the wind of the turbine bed, right? You should to use the smaller one. Okay, this is the in the step of the generation, and in this case of the pre-processing, you should to set up about the simulation condition. For example, set up the fluid property. What is your property? Uh, the wind density and viscosity and so on. Okay, and you should to set up about the operation condition. What is the wind speed? what is the low original speed. Okay, this is the example of the uh, physical setup. Okay, in the step of pre-processing. Okay, after you set up your model, and the second step is the calculation. Okay, in the calculation of the CFD, the calculation will use the by using the uh, how to say, by using the integration technique, right, to show the the to show the equation, governing equation, right? For example, the governing equation of your problem, including with the continuity equation, Navier-Stokes equation, energy, and sometimes if the flow you uh, have the behavior of the turbulence, maybe you should to consider about the turbulence model, right, in your calculation. It is the step of calculation. After your calculation is finished, okay, the final step of CFD is post processing. Okay, you should to show your result. For example, you can show or you can visualize the flow field, the velocity vector, and streamline and pressure contour over your device. Or maybe you can calculate the power generation from your calculation, and you can uh, check your result with the with the external data to compare your accuracy of your calculation, right? Okay, this is the step of processing. Okay, in this example, I can show you, I will show you about the visualization of the full field of actual contour when the wind turbine is rotating, right? You can see the the difference of the pressure contour between the top and the bottom of of the aerofoil, right? Okay, this is the example of for visualization. Okay, this is summary of this step: CFD simulation, pre-processing, calculations, and post-processing. Okay, and for today, introduce about I will introduce about the simulation the with a commercial CFD software of Cardle company. Okay, actually the CFD software of the Cardle. Now I know about two software, right, of the Cardle company, to CFD software. The first one is the SC Tetra, and the second one maybe is the SC4, SC Flow. Okay, for the SC Tetra, the difference of the SC Tetra and SC4 is the math in the step of the math generation. Okay, SC Theta will generate the unstructured mix of theta hydro or the theta hydro math, right? But in the case of SC4, the math type of that one is the polyhedral math. Okay, for this video, for this video, I will show you the model of the flow by using SC theta, and the theta hydro element will generate in this software. Okay, this is the feature of the kicker, right? Sometimes SCT theta you can call SCT. This is the kicker. Okay, including with the main three parts. The first part, if you click here, is the key processor. In this case, you will set generate the CFD domain. Okay, so maybe you can import the CAD file. For example, you can import the CAD file from the SolidWorks by using the step file. and then you should to modify, or you can register the your CFD domain, okay, in SCT, okay. And for example, you can register the fluid bodily. For example, the inlet, what is the outlet, what is the solid surface, right? In this case, you should to save the CAD file or the model file. The model file of SCT is dot MLD. Okay, this is the step of the geometry generation in the P-processing. And the second step of the P-processing is the MET generation, right? And the concept of the MET generation of the SAT, the first one you should to generate the octet, right? The octet is the octet, the feature of the octet, like the square for the two-dimensional mesh and okay, how to say hectahedral, okay, maybe hectahedral octet you generate for the three-dimensional domain, and then for the octet file will generate the mesh file. That the mesh file will generate by to the tetrahedral element. Okay, this is the first one of generate geometry. The second one is for generate the mesh, and the third one is for set up the condition of your calculation. Okay, for example, set up the property of fluid domain, set up the property boundary condition, okay, and so on with equation you want to solve in this in your calculation, right? You can set up in this step of set of the setup analysis condition, okay. And in this case you will get the S file. S file is the setup analysis condition, okay, and then you will use the S file to calculation by in this in this in in this one, okay. This is the second step of the calculation, or in this software is called SCT solver, okay. You can see the monitor of your calculation, and you can see the how to say the tendency of your calculation is diverse or diverse or convert, okay. And you can see your monitor, the residual of your equation, the residual of energy equation, energy equation of the mass equation, energy residual of the momentum equation, and you can see in the monitor file of the SCT solver when uh, calculation, okay. And then after your calculation is finished, you will get the output file, right? You can get the output file dot FLD, and you will use the output file FLD to the third step of post processing, and you can visualize the fulfill of your food of your problem, and you can plot the velocity vector, you can plot the pressure contour, okay, and so on. You can manage in the SCT post, okay. This is the feature of the kicker, SCT kicker, okay. And for this tutorial I will show you with two types of uh, of the flow. The first one is the internal flow, and the second one is the external flow. Okay, for the internal flow, I will uh, I will simulate with the very basic of the two parallel of the flow between two parallel plates. Okay, for example, the Q-S flow, Poisson flow, and the mix between the Q-S and Poisson flow. This is the my planning of my planning of calculation for the internal flow. Okay, and the second one is the external flow. Okay, two case of my training that I want to show you. The first one is the steady simulation of for path the aerofoil, right? And in this case, we will calculate the lift and the drag coefficients of uh, the flow over the airfoil, and we will compare our result with the database, right? Okay, CLCD and so on. Okay, if we can, that is the first the first the first problem in uh, external in the external flow simulation. Okay, and the second problem, this one is the really really basics of the unsteady flow simulation. All right, in the case of flow over a circular cylinder, and you can see the Kalman vortex state behind the cylinder in the wake regions. Okay, and the Kalman's vortex behavior is the unstructured, right? And in this case, we will visualize the Kalman vortex state, right? And we can calculate the Kalman vortex frequency, and we can comparing with the technical data, right? And we can okay. This is the my outline of this training. Okay, the summary of this video is the introduction of the introduction of CFD and introduction about statistics of CFD simulation and the feature of the SC data CFD software of Cardle company based on finite volume but on t-dimensional finite volume. Okay, this is the feature and the outline of my training with two types of the flow, internal flow, external flow, and internal flow. All of my training I will simulate for two-dimensional problem because I want to save my uh, computational cost. Okay, this is my outline of this training. Okay, okay, and see you for to the next video of the first problem of flow of the internal flow between the two parallel plates. Okay, thank you for your attention, and I hope to see you in the next video. Okay.